Morning students. Today we are going to see about memory operations. Before going to the topic, let us recap what we saw in the earlier class. We saw about memory location and addresses. We know memory is divided into fixed size blocks called as cell, and each cell has a capacity to store bytes in terms of zeros and one. Each group of n bit is referred to as a word length, and this word length in a memory can vary from 8 bit to 64 bit, and group of this 8 bit is said to be a byte. This is what we have saw in the last class. And similarly, memory is stored in a particular place, and that place is said to be a memory location, and we can access the content inside the memory through this memory address. This is what we have saw in the earlier class. Today let us enter into today's topic, memory operation. Before going into memory operation, I want to refresh you regarding Big-Endian and Little-Endian method. I mean, it is two type of assignment method in which data are stored inside the memory. Big-Endian is used when lower byte of address are used for the most significant bytes of the word. As the definition says, if we have 8 bit of word, the lower byte will be at the topmost and the higher byte will be at the lower end. This is what the Big-Endian method is. Whereas in Little-Endian method, it is used to store when lower byte of address are used for least significant. If I have 8 bit of data, the lower byte will be at the lower location and higher byte will be present in the higher location. This is what Little-Endian method. Just the opposite will be happening in Big-Endian and the Little-Endian method. So this diagram shows the Big-Endian assignment method and the lower end assignment method. As I told, if I have a 64 bit data, that will be divided into 4 bytes. That is what the word length is. So in this diagram we have a word address consists of 0 to 3 bytes, and the fourth byte is at the second row. That is what this diagram implement. And similarly, this side, in the left side, you can see that we have the shells, which shows the lower byte is stored at the lower location and higher byte is stored at the higher location. So the storage of the value here in this sample example is given as D7C4. In Little-Endian method, C4 is the lower byte which is present in zeros location, and D7 is the higher byte which is present in the MSB, most significant bit. Whereas in Big-Endian method, we know the lower byte is C4, which is present in the most significant bit position, I mean in the first location, whereas the higher byte D7, the storage data D7 higher byte is present in the LSB position, that is least significant bit. Just the opposite, the both LSB and both the Big-Endian and Little-Endian method will be of opposite method. So now the topic is the memory operation. In memory, we will be doing basically two operations, that is loading and storing. Load operation can be also called as a read operation or a fetch operation, and a write operation can be called as a write operation. Store operation can be called as a write operation. So load operation, main objective of load operation, it will make use of MDR, memory data register, and MAR, memory address registers. The diagram shows the before execution and the after execution. So before execution, you can see in MDR hold a data. Okay, 3D is a data which is already available in MDR, and MAR is holding a memory location, which means I am going to transfer that content to the memory location 2003. So here during the load operation, it will transfer the copy of the content to the specific memory location which is present inside the processor. So the content remains unchanged. So the processor will send this address to the particular location and request to be stored. So here, according to this diagram, before execution, we have 3D data and MAR is holding 2003 3 is the memory location. MAR is nothing but the memory address register. So I want to load the content which is in MDR in the memory location 2003. So that will be done here. See, this diagram you can see here after execution. Now the 2003 will be replaced by the different data. That is what this diagram shows. Okay, so come on guys, let us move on to the quiz regarding likewise the store operation also. When a store operation happen, memory will the content of transfer will be happening place between the processor and the memory. After the operation has been completed in the processor, the data will be stored inside the memory. So here, coming back to the quiz, what is the answer? The smallest entity of memory is called as, is it a cell, a block, a unit, or an instant? Yeah, correct, it is a cell. So let us go to the next quiz. Suppose if I have a 24-bit address, and what will be the address generated in this address space, whether it is 1024 or 4096 or 2 power 48 or 16 lakh 777,216. As you know, memory will be stored in terms of 2 power. So 2 power 24 is the answer will be D. 16 lakh 777,216 will be the answer. And third one, if a system is of 64-byte machine, what will be the length of each word? What will be the answer? Is it 16-byte, 12-byte, 8-byte, or 4-byte? Yeah. Yes, can I get the answer? Yeah, it is of 4-byte. How it is 4-byte? 64 divided by, yeah. How it is 4-byte or 8-byte? Answer. So, what is the type of memory assignment used in Intel processor? Intel processor will make use of whether it is a medium-endian, little-endian, or big-endian. Intel processor will be making use of little-endian method. You can reference it in this diagram itself. Here, let me go back. See, here Motorola processor make use of Big-Endian method, whereas Intel processor will make use of little-endian method. Okay. Pentium also make use of little-endian method. Okay. Thank you guys. Kindly refer the content, refer the textbook which is available, and also the reference book. Read the content and prepare. Thank you.